Good morning, folks. Hopefully you guys are all well rested from last night's party. And if not, feel free to close your eyes and take a little breather here. All right. My name is Alex Fontana. I'm a solutions architect for Microsoft Solutions, Microsoft products on VMware. I've been at VMware for about 6.5 years. The first 5 years at VMware I spent in IT as an IT architect. And during that time, I got the chance to virtualize a lot of the Microsoft products that you might have gone to sessions about this week. The past about year and a half, I've been working on Exchange solutions on VMware, talking to customers, evaluating designs for customers, and just trying to give general guidance around virtualizing Exchange 2010 on vSphere. So we're going to talk a little bit about that. Obviously, disclaimer, you guys have all seen this, I'm sure, many times. So we'll move on. So a quick look at the agenda. We're going to just give a very, very brief overview of what we've seen as far as Exchange virtualization in the market. I talk to customers just about every day that are about to embark on virtualizing Exchange. So, there's a few things I can share. And then we're going to look at some performance numbers. How does Exchange perform on vSphere? What have we seen? We're going to look at some best practices. We'll do some availability options, and then we'll wrap this up and we can do a quick Q&A. So you may or may not have seen this slide. Really what we're trying to show here is a lot of our customers began their journey to what we hope would be a fully virtualized data center at the stage where they're virtualizing the low-hanging fruit, the infrastructure, domain controllers, DNS servers, DHCP. As that's been, kind of the easy way to go, the easy in, we see what else can we virtualize? And we really get to the tier 1 applications. And I think for most organizations, Exchange is a tier 1 application. It might not get as much of the, maybe the quote-unquote praise that something like an Oracle or an EBS system gets. But it's one of those things that when customers come to work, they expect it to work, right? It's the lights are on. They expect to flick the switch and it just works. So it is a tier 1 application. And that's the middle column here. So we see that as you're deploying these tier 1 applications, you're actually hitting the tipping point to where you're becoming a more agile environment and you're actually deploying IT as a service. Obviously that third one at the right is going to be where you're actually doing things like vCloud Director and you're in your own private cloud or maybe even a hybrid cloud. So what's been going on with Exchange over the past few years? We did a lot of testing, a lot of marketing around Exchange on VMware as early as 2007. It wasn't as, or I guess people weren't as open to it, and there's a couple reasons. One, we're talking about Exchange 2003, arguably one of the most difficult applications to virtualize. It was difficult to run on physical, right? I mean, if anyone here has experience running a large Exchange 2003 environment, you were probably rebooting a few times. Occasionally, you have the memory fragmentation. It's a 32-bit operating system. You fast forward, Exchange 2007 came out, and it became a little easier. We set a world record of how many mailboxes we could support on a single piece of hardware. Fast forward to last year. At a certain point, we got to where we weren't having to sell Exchange virtualization as much. It was more of folks coming to us and asking us how to do it. I personally wasn't having to sit on calls for 15 minutes defending why you should virtualize. I was getting calls asking how we should virtualize. So obviously the adoption's there, and there's a few reasons. So one of them is Exchange itself has gotten way better than it was before. Obviously, I talked about 2003 and how much of a pain that was to not even just virtualize, but support on physical even. You go to 2010, we're 64-bit. They've completely redesigned the database, a lot less I/O. Couple that with the fact that VMware, let me build this out real quick. The VMware itself has made great strides. And to the point where we don't really have to talk about the limitations of vSphere anymore with vSphere 5. 32 virtual CPUs, which is more than the minimum supported, the maximum recommended from Microsoft. Right? If you go with a multi-role server, the maximum recommended is 24 cores. So we've got that covered. A terabyte of memory, you're not going to be putting a terabyte of memory in an Exchange VM. I will say that the 1 million IOPS number is a bit absurd. They did do it, but you're not ever going to see anything like that out of Exchange VM. So we've gotten past the limitations. On top of that, obviously we have very, very powerful hardware. Right? We have a lot of processor cores. We have a lot of memory. Things getting cheaper. It's very easy to get a box that we can't efficiently use. So a few support considerations here. There are a few support options. Back in 2008, we got full support via SVP. And that's pretty much the option for anyone, whether you're a Premier customer or not. Premier customers have a bit more leverage. And they've been able to, typically in some cases, get away with a lot more than some of us that have to pay per incident. There's also support through OEM channels. So if you go to one of the server vendors and you buy the complete package, which usually entails a server, an OS, and the application, you typically get support through that partner or through that channel. And then obviously you can always call VMware support. VMware support will take your first line call, and they will try to work with you and resolve the issue. If VMware support can't resolve that issue, they have a couple options. They can use TSANet, which is a back channel to various vendors, and one of them being Microsoft, to where you don't have to get involved. Right? We'll work with Microsoft, and we'll get the problem resolved. And as a last resort, if we need to, VMware is a Microsoft Premier customer. So if we need to open a Premier case, we'll do that on your behalf, and we'll manage the case. So, is anyone concerned about support? There's 1, 2, all right. So like last year and the year before, all the hands went up, so that's awesome. This slide is mostly informational because really the bottom half doesn't apply to Exchange, but just so you know, as far as Exchange 2010 clustering, DAGs, CCR is concerned, there's really no restrictions. As far as, if anyone's looked at the MSCS guide from VMware, you see that it's chocked full of limitations and restrictions. RDMs, fiber channel, etc. Only 2 nodes. That doesn't apply to DAGs, to CCR. Right? We don't consider that traditional clustering, and really neither does Microsoft. With 4.1, it made a few enhancements. We're now supporting HA for traditional clusters, but really what I'm trying to drive home here is there's no restrictions. You don't have to go with fiber channel disks. You don't have to go with RDMs. You have options. Anything you would do with a normal VM, with any standalone VM, you can do with an Exchange 2010 DAG node. So what specifically is supported and what is not supported? So all the server roles are supported as far as virtualization is concerned. Unified messaging, you have to be running Service Pack 1. And this is about, from Tech Ed timeframe, this was announced right around the time when they announced the next one. So combining Exchange 2010 DAGs with HA and vMotion, which means you can now use DRS as well. Thick virtual disks, so fully provisioned VMDKs, or raw device maps, whichever you choose, typically depending on your technical requirements, and we'll get to that a little bit later. And then whatever protocol that you want to use to get to the disk. So what's not supported? This first one is a question that I've gotten at this show more than any other question. Can I run Exchange on my NFS-backed VMDKs? Yeah, you can. It's not supported, but you can. So I asked some of my storage vendors, how do your customers that are doing this on NFS get by the support caveat? No, they're Premier customers. And we've seen that. We've seen that before Exchange was supported on VMware. Premier customers get the call answered. And they get the call answered, and they get pretty much best effort support. So, One of the things that I've seen customers do with NFS is maybe they won't put Exchange on there, or they won't put Exchange data files on there, but they'll put the OS disk on there because that's their standard. So there are some options. Microsoft specifically says the Exchange data cannot reside on NFS. Thin disks, and to be quite honest, we don't recommend thin disks for an application like Exchange. So that one doesn't seem to be much of a problem. And then snapshots. And really snapshots, if you're ever going to roll back. So there's a lot of applications that take a snapshot and back that snapshot up and are never going to be rolled back to the snapshot. And those are okay, but it's snapshots with the intent of rolling them back that it's not supported. And then, of course, the benefits of vSphere. I mean, I think everyone is well aware of the benefits, or else you wouldn't be here. But a couple that I want to point out. Utilizing all the server cores. Like I mentioned earlier, servers are extremely powerful nowadays. If I want to deploy a 12-core server and I want to make some decent use out of it, with the processor cores that we're seeing today, it's pretty easy to put 12, 13, 14,000 users on that one box if I want to make any type of use out of that server. For some folks, that might be all right. I personally have a problem putting that many active users on one OS image, just because there's a lot of factors there. There's the OS itself. If I can break that up into multiples, then one could probably get more efficient use out of that. I could probably lessen my fault domain there, and of course, like I mentioned earlier, make better use of that overall hardware. Operational advantages. If the majority of the environment is already virtualized, I probably have some decent procedures set, and I have a way of doing things. And having to change that for one application might be a bit of a burden. If I can take advantage of the same tools that I'm using for everything else, for maybe 60, 70% of the environment, it's probably going to make my life a little easier come time to do maintenance or deploy new machines. And then lastly, you have a little bit of flexibility when it comes to HA. If you can and if you evaluate it, and if you see that you can get close to the same availability as you would with the DAG, you might be able to take advantage of some of the VMware features and not have to go down the route of deploying 2 times or 3 times or 4 times the storage for extra copies of the data. All right, so quick note on performance. So when we do these performance tests, we use the same tools that Microsoft uses and that you use in your proof of concepts or pilot environments to validate the underlying hardware and the design. So jet, stress, and load gen. So this slide is a bit of an old study, but I bring it up for one reason. It's the last time we did a physical to virtual comparison. And this was on vSphere 4, and this was Exchange 2007. At that time, we saw a hypervisor overhead of about 5%. Now, as vSphere has evolved, 4.1 and 5.0, and as Exchange has evolved, we've seen that number come down to the point where we don't do this test anymore. But I think it's good. I mean, I like to see the number. I like to see the comparison between physical and virtual. It's great that the virtual machine could perform, but how does it stack up to a physical machine? And this is, a good comparison here. But again, it's the last one we've done because we don't really see it to be much of a value anymore. We've gotten to the point where the hypervisor overhead is pretty minimal. So we go into tests like this one. This is Exchange 2010 on vSphere 5. The comparison we did here on the left is vSphere 4.1 against vSphere 5. And what we wanted to see was, how do the virtual machines compare? And is there any better performance in vSphere 5? So if you look at the two virtual, then the one on the left is a scale-up test, a single virtual machine, 2 virtual CPUs, 4 virtual CPUs, 5 and 4.1 pretty much on par with each other. Where 5 excels is in the larger virtual machines. So it's actually more conceivable now to go with the larger virtual machines, the 8 virtual CPUs, 12 virtual CPU VMs, And we see that the 8 virtual CPU did outperform the vSphere 4.1 VM by about 5%. And then, of course, we couldn't do the comparison with 12 virtual CPUs because it's not supported in 4.1. But you can see that you could actually get there and utilize not a whole lot of the processing power. And that kind of goes back to what I was saying about the processors these days are so efficient. Our performance engineers don't use the calculator for this, so they don't push these things to the limits that the calculator would expose. But they go with the number of about 1,000 users per processor. And then on the right side, we have a scaled out test, 4 virtual CPUs per VM, 4,000 users per VM, scaled to 16,000 users on a single host. And then this last one is also an older one, but I like to put it up here just to make sure folks know they have options when it comes to the storage connectivity. We did Fiber Channel, iSCSI, and NFS, and they all worked great. They all passed load gen successfully. Obviously, Fiber Channel was the best performing and least impact on the host, least overhead to the host. But NFS and iSCSI also performed well. So there are options. You don't need to go the Fiber Channel route if that's not your standard, or if you're looking to save a few bucks here. Of course, NFS is not supported by Microsoft, but Premier customers might be able to still take advantage of that. So summarizing performance, obviously, like I mentioned before, the overhead that we see is very minimal. Our partners test it. Our storage array vendors, server hardware vendors, do the same test that we do, see the same results. vSphere 5, vSphere 4.1, whichever one you're going to deploy on, you're going to get darn good performance and close to native. And of course, whichever storage platform or protocol you want to use to access your Exchange data storage is going to most likely work out, assuming the underlying storage is architected correctly. We'll talk about that in a few minutes. So we'll talk about some best practices. I'd like to get started with virtual CPUs. I get a lot of questions about, how should I design virtual CPUs? How many virtual CPUs should I give to a VM? And what are the ramifications? So one of the main things that we talk about is, and this is very specific to Tier 1 applications, and we're kind of sticklers on this one, is we don't like to see overcommitment. And the reason is we went through the process of scoping out hardware, of taking that proposed processor that we're going to use, running through the Exchange calculator, and making some assumptions that we're going to try to run this VM as efficiently as possible, or this hardware as efficiently as possible. And that's really based on the throughput of the CPU. If we were to start overcommitting that CPU, that number is going to go down. So it's not to say that you can't overcommit. What we want to drive home is don't start off overcommitted. Right? Deploy your architecture, deploy your Exchange design, and let it run in production unovercommitted. Establish a baseline and realize, all right, can I overcommit? And we would typically recommend you can start overcommitting little by little until you reach a point where you're satisfied with your consolidation level and you're satisfied with any latency that's being introduced because of the overcommitment. Another point on this slide, NUMA. So Exchange is not NUMA-aware, and that's fine. ESX is. So one of the things we've seen is, we're really talking about squeezing out that last 5% of performance here. It's not going to make a huge difference, but you're going to get the best performance when your ESX VM can stay within the NUMA node. An example, and this performance study is out there on VMware.com, vSphere 4.1 in Exchange 2010. That test was done on a 12-core server with 96 gigs of RAM. The recommended RAM configuration for the virtual machine per the mailbox calculator was 72 gigs. So that's going to span 2 NUMA nodes. We did a test with 64 gigs. We did a test with 48 gigs. The 48 gig test outperformed the 64 gig test by a small amount, but simply proving the point that ESX will try to keep that VM on a NUMA node, and it will perform better if it doesn't have to cross over. Again, we're talking about the last 5% of performance here. And then obviously the last point here, the processor architecture is extremely, extremely important to understand if you want to get any decent amount of consolidation. And there's tools we can use to understand how many mailboxes we can get per core or per vCPU. And we'll take a look at those in a minute. Memory, pretty easy. Honestly, it's almost the same as the virtual processor. We don't want to see any overcommitment. The last thing we need for an Exchange VM to do is to start swapping within the guest, is to start, introduce any kind of memory ballooning, and God forbid any type of ESX host swapping. That's when your customers are definitely going to pick up the phone and start yelling. You guys can read through the rest. Just one that I'm going to point out, the unlimited, what this graphic is showing here. There was a time about ESX 3.5, ESX 4.0, when we were getting a lot of calls about performance issues with Exchange VMs. And it wasn't really limited to even the mailbox server. It was sometimes the hub transports and sometimes the CAS servers. And it was because the unlimited box became unchecked or someone unchecked it. And there was a limit placed on the VM. So if I allocate 4 gigs to a VM, the VM will get 4 gigs. It doesn't only use 4 gigs of physical memory. It requires some additional overhead. And that overhead is used by the hypervisor to run that VM. And what it seemed like we were seeing was that when this was unchecked and the limit was set at 4 gigs, which is what we allocated to the VM, that overhead wasn't able to come from physical memory. And we were having to swap. And we were seeing CPU spikes within the guest. And literally checking this box and applying the change would instantly fix the problem. So it doesn't seem to be as much of a problem, but being as paranoid as I am, I always go back and check this. And I always make sure that this is set to unlimited. So just a quick overview of the storage concepts when we're talking about virtualization. From the physical perspective, physical layer, nothing changes. We still have storage arrays and LUNs. How we present storage, that's where we get a few options. We have virtual disks and we have RDMs. And there's maybe not pros and cons, but there's reasons why you would choose one over the other. But before we get to that, a few best practices here. So one of the questions that I get very often is, should I use PV-SCSI for my vSCSI adapters for Exchange? My general recommendation is, if you use PV-SCSI adapters today for other applications, then go ahead, by all means. If you don't, and you haven't made a practice of it, and you're just using the default LSI logic driver, don't change. All the testing that we've done, all the testing that our storage partners do, is with LSI logic. I haven't seen one yet that's used PV-SCSI adapter. And that's not to say that the PV-SCSI adapter is not suited for this application. It's LSI logic is the default. And we don't want to change things if we don't have to. I haven't really seen a reason to go down the route of the PV-SCSI adapter for Exchange. You know, I mean, if we break it down, Exchange 2010 is not as I/O intensive as its predecessors. The dedicated VMFS volumes, I get some questions on. Really, the point here is, if I deploy an RDM for a mailbox VM, it is dedicated to that VM. No one can encroach on my I/O. There's a one-to-one mapping there. If you're going to go down the route of using VMFS, we like to see kind of the same approach. Either use that whole VMFS volume, that whole physical set of spindles for exchange, and whether you carve it up into multiple VMDKs for different exchange servers or for the same exchange server, that's all fine and dandy, but we don't want to see other applications coming in. It's really more of I'm not going to let myself get encroached from other VMs because I left 500 gigs available on this VMFS LUN and somebody saw it as free space. That's really all that point is trying to make. Multiple SCSI adapters. So we used to give guidance around deploying multiple SCSI adapters and separating the database and the log traffic. What we've seen in testing is that you can get far better throughput if you actually start mixing those workloads. So if you have 2 virtual SCSI adapters, and we'll exclude the one for the OS VMDK, the OS is on its own, and we have 2 more for databases and logs. If we have 10 database LUNs and 10 log LUNs, we would much rather like to see 5 database LUNs and 5 log LUNs on vSCSI adapter 2, and the same on vSCSI adapter 3. We see better throughput. And then eager zeroing thick the VMDKs if you're going down the route of using VMDKs. There's a couple ways you can do this. vSphere 4.1, I have the graphic here. You want to enable that VMDK for FT, for fault tolerance. That's going to zero it out. vSphere 5, you want to use the thick provision option. It's going to take a little bit longer to provision that disk. You're not going to get to see it as quickly into the guest as if you just went with a lazy zero disk. But as far as performance is concerned, you're going to be much happier having those zeros written immediately versus having to incur 2 writes the first time that disk is written to. If you forget to do this, you can still fix this from within Windows even. After you've presented the disk, you can uncheck the quick format option within Windows, and that'll basically do the same thing. If you go down this route, if you do take the time to make sure that it is eager zero thick, you can go ahead and leave the quick format option enabled within Windows because it won't touch the disk. It'll already have been zeroed. So why would I choose VMFS over RDM? We used to say if you're clustering, there might also be some performance benefits from RDM. That's kind of old school thinking now. As of about 3.5, and especially in 4.0, 4.1, and 5, the performance differences between VMFS and RDM have really been negligible in the testing that I've done myself, being the very paranoid exchange administrator for VMware IT. I saw microsecond differences between RDMs and VMDKs. So what the guidance that we give now is really, 1, are you doing any type of backups, or is there anything technically that will require you to use an RDM? And what it really boils down to is, are you doing any type of hardware-based VSS? If you're trying to back up Exchange using snapshots or clones at the array level, then more likely than not, you're going to have to go the physical RDM route. If you're not, if you're doing software VSS, if you're doing something like Microsoft DPM or something like Aperture, you could get away with going the VMDK route. And what I'm seeing from customers is pretty much a 50-50 split. I see RDMs from shops that are a little more conservative, and they're still kind of holding on to that notion that RDMs are faster. Maybe they're a little more comfortable. And there are other ones that are doing RDM is because of the physical, the hardware-based VSS. And the other half are happily plugging along with VMDKs. So the choice is really yours. I was going to say we don't. I guess VMware doesn't prefer one over the other. If you ask me, I'd say go the VMDK route. RDMs are a pain in the butt to manage. Networking best practices, really nothing specific to Exchange here. This is really vSphere best practices for networking. But obviously they still apply. So a couple best practices for using DRS and HA. DRS works a whole lot more efficiently when it has more options, when it has the option to place VMs in more spots, more slots, as we call them. And that's not to say that you need to keep your Exchange VM small. Obviously, if I'm deploying a solution for 100,000 mailboxes and I can have 10 mailbox VMs versus 20, I'm probably going to go the route of the 10 mailbox VMs. But if you are looking to take advantage of DRS, you're going to have a little more flexibility if you try to keep the VM small. To be completely honest, the majority of the customers that I talk to are going down the route of a dedicated cluster for Exchange. So for whatever reason that may be, there ends up not being a whole lot of overcommitment there. So maybe DRS isn't a huge factor. This really comes into play in hosted solutions, in shared environments, where I'm deploying Exchange into an environment that isn't dedicated to Exchange, that there are other applications, and there might be some level of overcommitment, and we might start seeing DRS moving things around. In those environments, I would definitely, even if those environments were large environments, I would definitely say keep the VM small. You're going to be trying to take advantage of DRS. Let DRS do its job a little more efficiently. And then just jumping down to HA. For standalone mailbox servers, for public folder servers, hub and CAS servers, we can utilize HA to give us that extra bit of protection. A little bit more protection than we would have in the physical environment. HA can monitor the VM, establish a heartbeat with VMware tools, and realize if that VM or if that OS, guest OS, has become unresponsive. So we have the heartbeat with VMware tools. If we lose that, we'll start looking at network I/O and storage I/O. And if we realize that the VMware tools heartbeat's gone, the network I/O, we don't see anything, storage I/O, we don't see anything, we'll go ahead and kick that VM and get it restarted. So it's not really in-depth guest monitoring, guest OS monitoring, or application monitoring, but it's pretty decent indication that something's gone wrong with that VM, and we can kick it over. So with 4.1, we introduced DRS VM and host groups, and these are pretty critical when deploying multi-tiered applications like this, where we have multiple points of redundancy, and we want to make sure that we maintain that redundancy. If we're taking advantage of things like vMotion, we want to make sure that our two CAS and hub VMs don't end up on the same host, obviously. Or we might have multiple chassis, and we might want to make sure that not all of the CAS and hub servers end up on one chassis. We might want to create a logical grouping of those ESX hosts within the chassis and a logical grouping of the CAS and hub servers, and apply rules so that they don't end up on that same chassis or even on the same rack. So for DAG nodes specifically, we want to make sure we keep them separate. Remember, DAG nodes of the same DAG, obviously we can have more than one DAG in an environment, but DAG nodes that are in the same DAG should typically not reside on the same host. If you follow Microsoft best practices, the databases are going to be spread out among all of the DAG nodes, which means that if we had two DAG nodes on the same host, we could potentially end up with the active and passive database on the same host, something that we don't want to have happen at least for very long. So members of the same DAG create a rule, an anti-affinity rule, and don't let them be on the same host. If you have multiple DAGs, then those guys can share the same host, and you can get a little better use out of your hardware that way. For other VMs, for maybe not public folder servers, but maybe public folder servers if you're doing any type of PF replication, CAS and hub transport servers, you want to go with the should not run on rule. So the difference between should and must, one's a soft rule, one's a hard rule. And by hard, I mean it's a hard rule. It will not run, it will not power on that VM. Excuse me, on that host. So my poor attempt to make a should run rule here is the dotted green line. Basically here, if we have an outage, that other VM, although it's not the best place for it to run possibly, but if we have an outage on that right side, on that chassis or on that rack, we can get those VMs to power on. DRS will power them on the left-hand side there. When we fix whatever happened on the right, DRS will come back in and move that VM back over to where it should be. If we had a must-run rule, come failure time, we're just not going to power that VM on because none of the hosts that it must run on are still up and running. And then vMotion and DAG nodes. So we published a paper earlier this year, right around the time that Microsoft released their support for DAG nodes and vMotion and HA. And some of the best practices that came out of that testing that we did to publish that paper were pretty much right on line with what Microsoft had put out. So jumbo frames. I'm going to be completely honest. When we went out of the box and started testing, best intentions, vMotion our DAG node, and we had database failovers. The application stun time, the amount of throughput that we were sending to the mailbox VM and the size of memory was a little too much for the vMotion. The stun time was enough to cause the databases to fail over. So we started looking into what we could do to improve that. Excuse me. One of the things that we did was enable jumbo frames. As soon as we enabled jumbo frames, those problems went away. Now, realizing that not every environment is going to be able to support jumbo frames end to end, we looked at other alternatives. So we went back, set everything to default, no jumbo frames, and we started playing with the cluster settings. Now, the cluster setting that worked for us was changing the heartbeat interval to 2 seconds. And a Microsoft cluster can survive four iterations of a loss. So basically about 8-9 seconds. With this setting set at 10 seconds, it'll fail over. With the default setting, it's 5 seconds. So we changed this, no jumbo frames. We were able to vMotion with no problem. Now, obviously, I mentioned earlier that a lot of the customers that I talk to are going down the dedicated cluster route. There might not be a whole lot of vMotion, there might not be a whole lot of DRS. But if you're looking to take advantage of it, one of these two settings, or both of them even, are going to definitely help you out and avoid any type of database failover. The biggest use case that I've heard of for using vMotion with this level of an application is maintenance time. So the vSphere admin wants to take his host down for maintenance, and he doesn't want to have to go and talk to the Exchange guys. He doesn't want to say, hey, all right, I'm taking my host down for maintenance. You're the one VM that can't migrate off. Do whatever you have to do. Exchange guy has to go in and fail over databases, shut down VM, shut down the VM, bring it up somewhere else. As little as it may seem as far as effort's concerned, that was probably the number one complaint, I guess, that we got before this was supported. So a little bit on capacity planning. So what do I need to look at from an Exchange perspective before I start looking at my design, before I start considering hardware? So obviously we want to look at things like message size. What's the average size of the message that's traversing the Exchange environment today, or whatever the mail environment is? What's the average message or average inbox size? What's the average mailbox size? Plays huge into the amount of CPU that's going to be required. Am I going to do any type of deleted item retention? That's going to increase our storage requirements. Anyways, all of these metrics can be looked at or can be evaluated using tools from Microsoft. So the Exchange Server Profile Analyzer. If you're handy with log parser and you have a bunch of message tracking logs, you can get really dirty and start looking at that stuff. If you have MOM or SCOM, you can take a look at metrics using those tools. Once you have that data, once you know what you're designing against, then it's time to really take a look at how do I want to design this Exchange environment? Do I want to go down the route of a multi-role server? Am I okay knowing that if I need to do any maintenance to the CAS server or the hub server, I might need to take down the mailbox server because they're on the same VM or same OS image? There's been more and more push to go down the multi-server route, and it seems to me that it stems from the fact that the server hardware is pretty darn powerful, and we got to make use of it somehow. So let's stack more onto the same host, onto the same native physical box, to try to get as much efficiency out of that box as possible. Well, you don't necessarily have to go the multi-role route. You can go the VMware route and start breaking up the roles if that's the way you want to manage it. Obviously, there's a case to be made around multi-role servers. I have a bad taste in my mouth from them, just from deploying a multi-role server solution at VMware and realizing about a day and a half into it that some of these engineers at VMware have 60,000 items in their inbox, and when they do an IMAP fetch, the hub transport service stops working. So we start queuing mail. So that's just one of the things to keep in mind. How much availability do you need? Okay, that's going to be extremely key into how our environment is designed. Not only for the number of VMs that we deploy for the mailbox role, but also for the storage. And then database size. The recommended, or not recommended, but the maximum supported size or maximum recommended size for an Exchange mailbox database is 2 terabytes. And that's when you have some type of high availability, so a DAG. 2 terabyte databases are great until you need to back them up, restore them, or perform maintenance on them. Now, if you have a hardware-based VSS solution like snapshots or clones, then it becomes a little more palatable, right? We can back it up and restore it, more importantly, pretty quickly. Maintenance should still be a consideration because we're still going to be doing that nightly maintenance, or if you're so daring to let maintenance run during the day. But it's a lot of data that we're going to have to comb through. The other consideration for that is typically if you're looking to take advantage of the hardware-based VSS quick restore features, typically you're going to have to go with a 1-to-1 ratio. So database and log LUNs will need to be separate. They'll need to be on their own LUNs, because what we're doing when we restore a VSS clone or a snapshot is we're basically rolling back that disk, right? That could, if you're going with maybe smaller database sizes, or you just have a lot of databases, or you have a large cluster, a large vSphere cluster, you could start getting up to that 255 LUN limit of ESX. And really, at the point that we're talking about a vSphere cluster, that 255 ESX LUN limit, it really is effectively a cluster limit, because we're going to map all those clusters, all those cluster nodes to the same storage. So, you know, I've kind of been going on and on about how the hardware is extremely high performing today, and it makes us, if we're going down the native path, it makes it hard to be flexible. When we start carving that hardware up, we have a few choices. And these are rough numbers, but these are the numbers that our performance team has worked with. You know, roughly 1,000 users per vCPU. It's going to be different for every processor, as I'll show you in a second. But that's the number they've worked with, and we've seen good results with that. The other thing to consider is if we do go down the route of the multi-role, the recommended upper limit for CPU utilization for active mailboxes is about 40%. When we start breaking out the roles, we can get a little more efficient with our mailbox processing, to where it's, you know, the recommended upper limit is about 75 or 80%. So here's an example of how much of a difference a processor can make. Microsoft's guidance, Microsoft's best practices, Microsoft's really baseline numbers come from internal testing that they've done. And their internal testing is based on this CPU. It's an older CPU, and it's pretty slow. So if I plug that CPU into the calculator with a average workload, 6,000 users, and I take the CPU that they're looking at, and I use this tool from Microsoft, which is a great tool, the processor query tool, which basically queries the spec website for throughput results for a given processor. I can see that for that 4-core chip, I'm getting about 81 on the throughput rating from spec. Plugging that number into the mailbox roll calculator, I can see that my 6,000 users would already be over the recommended upper limit processor utilization number. So it's about 83%. If we go with a different processor, the X5660, same workload, and go to spec, we see obviously this is a 6-core chip, so if we just use this number as it is now, it's not going to be a very fair comparison. Excuse me. We'll go ahead and break that down to a per core throughput number and plug that into the calculator. We can see that we're able to support those 6,000 users at about 50, 55, 56%. So, this is really just something to show you that it really does make a difference to understand how many users you can support. I've been part of a design review recently where this wasn't looked at, this wasn't taken into consideration, and the numbers that Microsoft was putting out there were used just at face value. And it turned out that the processor that this customer chose to deploy was an even older and even slower processor than the baseline Microsoft processor. So they ended up with a 4 virtual CPU VM that they wanted to support 6,000 users on. This processor, yeah, no problem. That processor, no, they were only getting about 15 to 1,700 users on it. And that's just the processor architecture and the throughput from that processor. It was about a 4-year-old processor. So then allocating storage for the VMs. So one of the things to consider when we're looking at where do we put these VMDKs, the OS disks, obviously consider clusters. So if you're deploying a DAG, you probably don't want to have the OS disks of 2 DAG nodes on the same VMFS volume, right? Single point of failure. Little things like that. If you're doing replication, if you're using SRM, it might be a good idea to not replicate the page file. It might be a good idea, especially for these Exchange mailbox VMs that are being deployed with 24, 32, 48 gigs of RAM. You probably don't want to replicate that extremely large page file. And moving on with the page file, do you really need that extremely large page file? Maybe. We shouldn't. I guess we shouldn't be paging a whole lot in Exchange, right? It's going to be a detriment to the application itself. So Microsoft has a support site that you can go to, and it basically gives you a few options for evaluating your page file usage so that you don't need to deploy a 48 gig page file. You can look and see what do I really need? How am I using the page file? And then obviously for database and logs, we absolutely want you to follow Microsoft best practices. There's no reason to deviate from their guidance, and it really is no different than what you would do on a physical machine. Hub transport and cache servers, it's really just a ratio of the mailbox servers that you've deployed. Same thing with Active Directory servers. And then when we're looking at this logical design of the Exchange environment, we do have to be conscious that there are some limitations in the hypervisor. Granted, in 5, you're probably not going to see them as much. Really, the ones that stand out are, again, the 255 LUN limit and possibly the 2 terabyte VMDK limit. Now, VMFS can be as big as 64 terabytes. RDMs can be as big as 64 terabytes, but the VMDK itself is limited to 2 terabytes. So if you're looking to go with larger volumes, that might be a situation where you need to go down the RDM route. What I did here was I took a reference architecture for 24,000 users, I broke it out into what I required at the virtual machine level. I threw in some public folder servers, some hub and CAS servers, and domain controllers, and ran it through the calculator, looked at what I needed as far as virtual CPU and memory, and then laid it out logically. This is really just, for those of us that need to visualize a design, it's a great way to really just look at your hardware, understand what you have available to you, and then place it logically. Obviously, if we're taking advantage of DRS, vMotion, things are going to move around. But it just gives us an indication of what do we have left over, what do we have available in case I do need to fail anything over. And then, of course, monitoring. So you're gonna continue to monitor Exchange the same way that you do today, whether that's using a homegrown tool, whether that's using perfmon, MOM, or SCOM. But we want to definitely be able to compare that with what the hypervisor believes is going on. And if we start running into issues, performance issues, or we think there's a performance bottleneck, these are some of the key counters that are going to help us find out where that is. A couple of ones to point out, obviously percent ready, which I mentioned a few times that we're not seeing a whole lot of overcommitment in Exchange environments. But if we're looking at an environment that is shared or is overcommitted, percent ready is one that we're going to want to look at. And percent ready is basically the amount of time that the VM has been waiting to do some work, but it can't do it because it hasn't been scheduled on a processor. And that's typically because either there's too many virtual CPUs assigned to the VM, or there's just a certain level of overcommitment at the host level. The other one that comes into play, especially for Exchange, and this is typically the number one issue that we run into when we go into a performance case for a customer that's deployed Exchange, the storage counters. So G average, D average, K average. G and D average, typically we're going to want to keep them under 20 milliseconds. K average is basically the kernel processing the commands. And if we have a problem at the SX level, we might see this number jump up. If we ever see the K average number go higher than 1 millisecond, we've probably got a problem. We've got a bottleneck at the SX host, and we want to call GSS ASAP. The other two numbers, we start seeing latencies there. It's usually indicative of a problem at storage level. Maybe not enough spindles or something going on within the fabric itself. So I won't go through the summary just for the sake of time here. Availability and recovery options. So obviously, what are we trying to protect? What's our SLA? How much time do we have when something occurs to get things back up and running? And can we incur any amount of data loss? Key questions to ask yourself when you're going down the road of designing a high availability solution. So you have two options. Marketing folks would have wanted me to put the second option first, but I'm a realist and I'm an Exchange guy, and I understand. I talk to customers every day. Exchange folks are deploying DAGs. I've had one customer in the past year and a half, excuse me, that's not deployed a DAG. And it's a pretty good sized environment. It's about 20,000 users. They're choosing to go the HA route, option 2. They don't see the need for DAGs. They don't see any database corruption. They have maintenance windows, so they can take that 5-minute reboot once a month or once a quarter. And they have a backup strategy that will allow them to restore their database pretty quickly. It's a hardware VSS solution, and they can have a database restored, a large database. I think their limit was about 500 gigs for their databases. They can have that database restored in about 15 minutes. So they evaluated all that, and they realized we can go the DAG route, but obviously we're going to need twice the amount of storage and twice the number of servers. So for them, that worked. For others, it might not. They might have more stringent SLAs, and they might not have those maintenance windows. They might not have they might not be extremely confident of their backup and restore solution. So the DAG route is fully supported. I'll just build this out real quick. In the DAG solution, databases fail over, and HA can be used to power on VMs on the other surviving hosts. Obviously, one thing to note here, there are 2 DAG nodes on the same host. That's a suboptimal configuration. We want to get that other guy back up and running and move that VM off as soon as possible. But what it allows us to do is it allows us to catch up on our transaction logs and keep the databases in sync so that when we do move it over, we have a lot less to replicate over. We have AppHA with 4.1. Specifically, Symantec has created an agent that's based on VCS that'll monitor the Exchange services. So traditional VMware HA, we lose a host, we power on a VM. Very simple. It's protection at the hardware level. There is some level of guest OS monitoring available. With application HA, we have an agent within the guest. We monitor the application. We have a failure, we'll restart that application or database. If we exceed a threshold there, that the application has failed a certain number of times, HA will kick in and go ahead and power or reboot that VM, typically on the same host. But it's an extra level of monitoring that's not available out of the box, but it doesn't require you to go down the whole clustering or DAG route. So as far as DR is concerned, you have options. Exchange out of the box can utilize delayed log replay, or even active-active scenarios if you choose to go that route, and if the network topology allows for it. But you have the option to have a delayed, lagged database copy in another site. Works fine. My only 2 issues with it are, actually one issue. It's manual, obviously it's DR scenario, so we want to have control over that failover. Probably the biggest issue with this is testing. So in order to test it, you have to fail over. And if you're okay with that, okay. But it's not ideal. And the other thing is, if we do have a disaster scenario where we have to fail over, at that point we're not protected, right? We have 1 copy of the data. Chances are, when we bring up the production site again, we're going to have to reseed all that data back over. The other option is SRM. So you have array replication set up. You can replicate the DAG data across the WAN to your DR facility. You can test without incurring a hit to production. You can test in the middle of the workday. Right? SRM will fence off the network at the target site and allow you to, obviously you have to have all of the required peripherals. So you have to have domain controllers. You have to have CAS servers. And those can be all part of the same SRM workflow. But you can fail that over, you can test, you can have a client, could be just an XP or a Windows 7 VM living on that fenced off network that you can fire up Internet Explorer and make sure you can get to OWA. You can fire up Outlook, make sure you can get to a mailbox. So just really the takeaways that I thought were things to keep in mind. Obviously, there's 100% support. It didn't seem like there was a whole lot of hesitance around the support that we have today. We can absolutely scale. And by going down the VMware route, you can design it to meet your needs, not meet the needs of having to load more onto this one piece of hardware so that we can use it efficiently. And then we have a lot of resources. So if you go to vmware.com/go/exchange, all the best practice white papers, design and sizing guides, availability guides are available there. And then once you go down the route of designing an environment, you can go to VMware Communities. We have a community set up just for Exchange. Well, and Domino and Bez, but it's mostly Exchange. And get advice from peers. I contribute to that community all the time as well. So they are introducing this bundle. This is new with vSphere 5. It's basically deploying your application and protecting it all in one. So you're going to be able to have Site Recovery Manager and vCenter Operations to monitor the environment. So that's something that if you are interested in, you can reach out to either your TAM or your sales rep. And then please fill out the survey. Definitely want to hear any feedback you have, what you liked, what you didn't like, so that we can make this even better next year. If anyone has questions, you can feel free to walk up to the mic, or you can just come up and track me down over here. I'll be hanging around for a while. Thanks a lot.